In this video, we are going to take a look at some workflows for procedural material creation. In Chapter 1, which is the first 3 videos, we jumped right in and created a material. This gave us a basic understanding of how Substance Designer works. Now that we have our feet wet, I'd like to talk about the theory of procedural material creation to give you some ideas on general workflows before we get into more complex topics in later chapters. Here, we're going to talk about procedural material classification, and I like to break a material down into 2 forms. I consider it either a basic material or a complex material. Now, both of these materials are going to be what we consider a base material, and when we're creating materials in Substance Designer, the base material is what we really focus on. Now, the key aspect of a base material is that it's reusable and that it's modular. Now, by reusable, I mean that the material can be shared across teams and used in many different projects. And with modular, I am referring to the material being used on any type of asset. And so we always want to keep this in mind when we're creating procedural content. Now, with the base material being the key concept, like I said, I like to break this workflow down into either a basic material or a complex material. Now, here you can see with the basic material, which we're looking at here, this is going to represent a single material. Now, here with the complex material, you can see that, well, we have 2 materials represented here. Here we have our metal, but then we also have this rust material that's being composited or blended with this metal material. So that is why I refer to it as a complex material, because we're taking 2 or more materials and blending them together to create a more complex base material. First, let's take a look at the concept of a basic material. Now, the core concept behind this is that it's a single material in a single graph. So here we have just this basic raw metal, and this material is just represented here in this single graph. And this basic material is then blended or mixed with other materials. So the goal would then be to take this basic material, instance this graph into another graph so that it can be blended to make the complex material. Here again, I'll stress that the principle behind any base material and this basic material, as we are discussing now, is it's designed to be reusable. Next, we have our complex material, and this represents multiple materials within a single graph. Now, this is the type of graph that we created in Chapter 1 in the first 2 videos. Here we have 2 types of materials. We have a rust, and we also have our metal, and these 2 types of materials are being blended here within this graph. And as you can see, this graph can be hard to decipher. We have a lot going on since we are actually trying to blend these 2 types of materials together. And this type of graph may or may not be reusable. So for example, if you design this graph where we have this rust material here and you didn't set up user parameters so that this rust can be disabled or changed, or if we can adjust the roughness and so on, what would happen is that we would possibly lock ourselves into only a specific type of project that this base material could be utilized in. This brings us to our material creation methods. Method 1, we are going to create basic materials that are designed to be reused. We are then going to blend these basic materials in a separate graph to make complex materials. So with method 2, we would create complex materials for reuse, where we would be then blending materials in a single graph to make a complex material. Method 1 is more of an atomic approach, where you're going to just break the basic material down into, a single graph for each type of material. Whereas method 2, we may do a little bit more layering to our material creation, all within a single graph. Now, that's why here I like to emphasize that method 1 can be a hybrid of both of these methods. So sometimes here with method 1, we're still thinking about creating a basic material, but it may have some other material attributes to it. So for example, let's say that we had like a brick and we wanted to have kind of some dirt on top of that brick, or in the example we'll take a look at here in just a bit, where we have brick and we have grout. So 2 types of materials there. Maybe we don't necessarily want to break those into their own, atomic basic materials. We just want to put that all within one graph. But again, the idea is that if we do create that, where we're blending multiple materials together in a complex kind of material setup, we do want to make sure that we focus on reusability as the key aspect to the material creation. So here you can see that I have two basic materials. I have this metal, and here I have a rust. And these are two materials that have been broken into their own graph. So in this sense, we're taking this kind of atomic approach to building our base materials. And now we would like to create a more complex material. So we create a new graph here, and we instance these graphs. So here you can see I have my metal, and then here I have my rust. We instance these basic materials or base materials now into this third graph, where we simply just blend them together here using this material blend node based on a mask. So we have a mask here to get our final output of our material. And as I said, this illustrates that method 1 creation process, where our base materials are more of an atomic process, and that we are going to blend them together using a material blend type node so that we can create a complex material. This does a few things for us. First, you can notice that this graph is very readable, and it's easy to see exactly what is going on here. Perfect for sharing this asset, especially in a team-based environment. Also, it makes it a bit easier to go back to a material. Say, for example, this rust material. We could just go back in here into our rust graph and make any types of changes that we want to do. As long as we don't change our outputs here, everything is going to sync up just fine. So we can just go into the rust graph, make changes, makes it a lot easier to make updates this way. We can more clearly see what's happening, jump back over here to our rusty metal complex material, and the update is automatic. Now, this is a very simple example, but you can see how a very complex material with maybe, 5 or 6 different material types being blended together, and how breaking this down in more of this atomic structure can help with providing updates, again, just enhancing the overall kind of workflow to this method 1 material creation process. Now, this process here, we're going to cover in the next video when we take a look at material blending, and we're just going to recreate this method here from scratch. Here you can see a graph that illustrates the workflow using method 2. So in this example, I have this brick, and this brick also has a grout material. It also has a dirt material. So I'm technically mixing 3 materials together, all within this single graph. And as you can see, again, this makes the process much more complicated. Here is an area where I'm creating a mask here for the grout. This grout material is actually being mixed in with the brick here in my color. It's being integrated in here with my normal, my roughness, and my ambient occlusion. So a lot of complex interaction here. Also, you can see that there is a lot of connection dependencies going on within these nodes to mix all of these materials together. And in that case, it makes it much harder to update. Here you can see I'm also layering in this dirt material here at the end. Now, there's nothing wrong with creating a graph this way, and I actually work this way often. Again, I like to stress that the whole idea behind Substance Designer is that you're creating these modular, tileable base materials that can be reused from project to project. So in this case, I would probably want to set up some controls so that I could turn off this dirt material so that it can be used in all types of projects. Another thing to think about as well is, notice, like I said, I have this grout material and that I'm mixing it in here within my brick in the areas of my color, normal, rough, and ambient occlusion, and so on, and I have this mask controlling this. Now, imagine if I had created this grout as a basic material, something that I did, very simply, and then when it comes time to create a brick, instead of having to recreate this each time, I could just go back to my library, grab my grout basic material, instance that in, and just mix it in here with my brick. Another strength of Substance Designer, the more material types that you create and the more basic they are, the more you have potential to reuse them in other projects. So again, you're just increasing your productivity and allowing yourself to work quicker because you're not having to just constantly recreate the same types of materials over and over and over. So the last thing that I want to touch on in this video is just material workflow itself. And so one of the things that I do is I always start here with the surface. And what I mean by that is I start by creating my height, my normal, my roughness map. Now the roughness map, which represents the micro surface detail of the material, and ambient occlusion. And then I always work from grayscale to color. So with that idea in mind, when I start to work on my height map here, I always start in this type of form. So I will start with the basic shape first. So here we have our basic shape, and you can see in this graph where we're starting with something very, very small to get a basic shape that we then make a brick pattern out of that. Now we want to start to add some details. So you start with your large, medium shapes, thinking about the overall silhouette here of what you're trying to create. Once you have that form, you then move into small details. And finally, once we have this data is when we can start to create our height, our normal, roughness, and ambient occlusion maps. Again, these are all grayscale maps at this stage. And then finally, we move into color at the end, keeping with this grayscale to color process. Now, if you've ever done any digital sculpting, like say with ZBrush, you'll see that this is a similar process. So for example, you may start with a base model, as we are here with a basic shape, and then you'll use like a large brush to kind of block out the overall silhouette of the form. Then you would subdivide the mesh to start working on medium details. Once you have that blocked in, subdivide again is when you start adding the smaller details. And again, that's the same kind of process that we're doing here inside of Designer. Basic shape, large medium form, and then small details. So we'll actually work through this entire process when we create a complex material later on in this course, and you'll be able to see how this plays out using this type of workflow. The important thing for now is just to get this broad overview of the type of mindset you want to have when you're working to create procedural materials. We want to think about which type of method. Do we want to go more atomic and create basic materials that are then blended inside of another graph? Or do we want to try to create all of the material blending within a single graph? Those are the types of decisions that you'll need to make when you start to create your own procedural libraries. And then in terms of actually creating the material itself, you want to think about the workflow for how you're going to navigate through that process. You're going to want to start with data that allow you to generate things like your height, normal, roughness, ambient occlusion type map. And then from there, you can move into color with the ideas that we're going to start from basic shapes, move to large, medium, small details, and just build this node by node until we get the type of shapes and forms that we need for our material.